Good morning, everyone. Today we'll be going through the assignment 2 of our computer vision course. Coming to the first question, we are asked to take a 10 seconds video footage using a grayscale camera from our depth from our OGD light. So, coming to the code, I have first imported all the necessary packages required, and then I have written a small block of code that will take one of the monochrome cameras as input. So, I have used the left camera over here and then take a video for 10 seconds. In this 10 seconds, I have moved the camera slowly from left to right to take a video of my object of choice. Next, we are asked to perform Harris corner and canny edge detection. So I've written code for both of these. All the video frames can be found in the folder video frames. So you can see the video frames folder having all the frames. Now coming to the next part of the question, in we perform Harris corner detection. After performing this algorithm, the output is stored in the file Harris corner detection. So you can see all the corners being detected on our video frame. We are also asked to perform the canny edge detection. Canny detection is performed on one of the frames from the video and is also stored in the folder. So you can see all the edges from the images being mapped out neatly. Coming to the second bit of the question, we are asked to pick another image from the set of images, and we have to map the images using a homography matrix. So I have written a function that will perform homography and print out the homography matrix. So as you can see, this is the homography matrix. The two images using with the help of homography matrix have also been mapped out, and the output has been stored in the folder. So you can see that these are the two frames, and there are parallel lines showing how points in image one map to the second image. I've also drawn a white border that shows how the orientation of the first image should be changed for it to exactly overlap the second image. Now moving on to the second question. In the second question, we are asked to implement image stitching algorithm and stitch five of three image sets that are available in the drive link that was provided to us. Now, since all the questions 2, 4, and 5, all of them use image stitching, I have decided to make a modular algorithm that can be used for all these three questions. So here is the function that I have written. This function takes three input parameters. The first two are the images that need to be stitched, and the third is the feature that we'll be using. So it can either be orb or shift. And then once this function is done executing, it will return the stitched image to us. Now, coming to the second question. In the second question, we are asked to stitch sets of three images. So what I've done is I have first stitched the second and the third image, and then I have taken the result and stored it in a temp variable. I have then stitched the first image and the temp variable together to make a total stitched image. So I have done this for five such sets. So there's a science center, Rialto team, sports center, and so on. All these outputs can be found in the folder image stitching. So this is how they look like. This is the sports center that has been stitched together. As you can see, the seams are over here. Similarly, here is the Rialto center that has been stitched together. In the fourth question, we are asked to take two frames from our video frame and then stitch them together. So I have again used the same algorithm, but since the fourth question mentions us to use the shift feature set, I have used shift as a parameter over here. The output again can be found in the folder. So as you can see, the output is stored over here where the two frames have been stitched together. In the fifth question, we are asked to stitch two frames using the orb features, and I have again used the same algorithm, the same function, only with the change in the parameter to orb, and you can find the stitched output in the folder. Now coming to the third question, the final question. So in this question, we are asked to implement an application that will compute and display the integral image along with the stereo and RGB feed. So I've written a function that will give the integral image as an output. Now integral image, um, so since the values in the integral image can be pretty huge, I have directly stored the matrix in a txt file as integral matrix.txt, and this matrix can also be found in the same folder. So here is the integral matrix, and yeah, so you can see that this, for example, is the sum of its left 2. So that is the end of assignment 2 of computer vision course. Thank you.